we see here is a rapid deployment tower. It really solves a number of problems with respect to both communications and monitoring, which can be portable and go into a situation where you need to establish communications or video camera monitoring. This particular application right here uses a gyrocam. It can be used and is being used on the border to monitor for border security. We've also all seen cell phone towers along the highways, and during natural disasters and situations that don't allow for normal wireless communications, the tower would be a perfect adjunct to going in and providing temporary communications. Within an hour, you can pull this trailer up with your dump truck, deploy it, and have your tower up and have the communications running in a matter of an hour. A couple of the keys to the tower is the spools of metal bands that go together to form the tower. The best way to make an analogy would be a tape measure. If you took 3 tape measures and you took them and made a triangle out of them, and then wrapped that triangle with aircraft-grade cable, you would make a relatively rigid tower that can be stored in a small footprint. And that's what you see here. We have 3 spools of aircraft-grade cable that wrap the tower together, the 3 bands of the towers together as it is deployed. The other key element is the computer controls. The controls allow the tower to be erected in virtually any kind of situation, and it's erected perfectly stably. In terms of operation, you go and select an operation from the user's console. In this case, we want to say that we want to raise the tower. We tell it to start. At that point, the tower starts to deploy. The aircraft cable wraps around the 3 tripods of the tower. Once the tower gets to a prescribed height, it will stop automatically, and at that point we would attach one of 4 guide wire couplings. This is one of the couplings that goes onto it. This coupling goes around the tripod of the tower. From here, a guide line is taken out to an anchor and then brought back to one of the anchor winch symbols. A computer perfectly monitors how much wire is let out of the winch assemblies, the loads, voltages, and things like that.
Now the winch assembly is on the trailer?
The winch assemblies stay on the trailer, so we attach a line with a turning block. The line would be attached here, the turning block would go out and be attached to the cable, and then the other end of that line would be attached to the collar on the tower. So as the tower starts to raise, you have a situation where you've got the winch on the trailer that goes out to the anchor, and you've got another line that comes back. So as this tower starts to raise, you'll see that the winch line is raised up, and it's perfectly controlled to make sure that the tower is perpendicular to the ground or to the area. One of the other things that makes this relatively unique is this entire trailer can be powered off of a battery pack that we keep on here.
All right.
So
take a look at that.
Yeah, it's here. The silver box right behind here contains 24-volt power, and with that 24-volt power, it's totally self-contained. It's multi-voltage functional, so if you were close to a building and you wanted to operate it off of a large extension cord, you could do that. If you had a generator, again, in a natural disaster situation, you've lost power. If you had a generator, you could deploy the tower off of there, or you could use the batteries that are already on there to be able to deploy the tower for communications, for monitoring, for whatever situations that you need.
How high does the tower go?
The tower can go up to 150 feet. It can be erected by 3 people in a matter of about an hour, and that's an hour from time of arrival to full deployment of the tower. It can be erected in up to 50-mile-an-hour winds with a 350-pound payload. It will also sustain, once it's erected, 80 miles an hour. The system is set up as it's designed so that you can't overpower it. There's a fairly extensive power management feature. If you take a look, there are actually 13 motors that are controlled through this one computer system. There's the main ejector motor, which raises the tower, and then each winch assembly has its own motor for controlling the tension and the length of the wire. So the computers that are tie this system together manage power very, very efficiently. That's the reason that we can take and operate our tower off of a battery that's located on the trailer site itself. In terms of safe operations for the operator, at this point you'd see that the tower is erected to a height of about 3.5 feet, and it's telling it to attach collar number 1. So at this point, an operator on top of the trailer would attach a collar, attach that to the guidelines. As soon as they're done, they just hit this, and the tower starts its operations automatically. So this is the only human interventions that is required, both for erecting or taking the tower down, is the attachment of the collar and the guidelines, or removing the collar and the guidelines. Aside from that, everything else is automatically controlled. If there's any unsafe situations in terms of overstressed loads or things like that, all of that information is contained on the system automatically stops. It's we've put it together in such a way that it can maximize its operational efficiencies and really minimize any kinds of dangerous situations that occur during the operations of the tower.
What happens if you have a power failure?
Once the tower, this is an attachment collar much larger than the other one. Once the tower is to the height that you want to use it, you would attach this collar, lower the tower down to its base, and then takes all the load off the mechanics and off the mechanism and everything that's there. And at that point, you can remove power because you're not. You're going to tie off your guidelines to the anchors. You're going to take the guideline ropes, bring them back to the tower. At that point, there's really no need for power because nothing's operational. The tower now becomes static. Everything that's attached to it is now operational. The tower, from a functional point of view, has accomplished its task by raising itself to its level in a safe and expeditious fashion. So at that point, there's no more power needed. The only time power again is when you want to take the tower down.
What type of vehicle do you need to transport it?
This kind of number of different packages, both in its minimal fashion, which is in essence about this trailer, this size of trailer. Well, I take about 2/3 of this size of trailer. It's about a 3,000-pound package, which includes the trailer itself. So it's really easily towed. This particular one we want to show today, I pulled it with my pickup truck.
Humvee would be no problem.
A Humvee is no problem. One other thing that's really unique about this is we've got an option that allows us to take the charging cable or a cable that has a NATO connector on it that is used to charge the batteries inside of a Humvee. If you didn't have the battery package here and you had no power, you could actually take the power off of the Humvee itself to operate the tower.
Okay. All right. Well, thank you very much.
Okay.